Okay, here in part 4, we're going to look at the past, the present, and the future of energy in the United States and in the world. This graph shows us the different kinds of energy that we use to turn generators in the United States. Coal, number one by far, it's around 50% of the U.S. energy is from burning coal to produce steam to turn the generator. The one thing that's been on its way up, if you follow this purple line, natural gas, because natural gas supplies are high and natural gas is cheap. That has been the up-and-coming way. You can see it passed over nuclear. Nuclear had been about 20% for many, many, many years, from the mid-'80s. It's been about 20%. It's staying about 20%. On its way down are things like petroleum, fuel oil, as it's called, or diesel, and hydroelectric. Really we're not using less of that. It's just that as a percentage it goes down. So in the future, what is this going to look like? Well, that's interesting. Coal supplies are fairly plentiful. We have not been building nuclear plants, but there is some talk about doing that. And natural gas is a finite resource, but we have been discovering more and more of that. Here's another graphic that shows basically the same thing. Similar numbers here. Coal, almost 50%. Natural gas, about half that. Nuclear is about 20%, and then all the others are minimal compared. And if you're interested in where nuclear power plants are, you can see that there are states that have really gone whole hog for this. Illinois is one of them. We have 12, I think it is, maybe it's 10. 2, 4, 6, 8, 10. Yeah, it was 11 of them. I was wrong in both counts. In Illinois, one of the greatest densities, Pennsylvania has a lot. There are a lot in the Carolinas. So back east, where there are a lot of people, and Illinois, where there are a lot of people, one looks like it's right on top of us, it's actually far north of us. We have a lot. And if you've ever driven across Missouri, this is the Callaway nuclear plant. You can see it from the Interstate 70 off in the distance to the south. And if you travel up through central Illinois, if on a clear day, if you're in the right place, you can sometimes see some of these nuclear power plant cooling towers. And here, worldwide, the U.S. is by far the greatest user of nuclear power. France made a decision a long time ago that they were going to go nuclear. Germany did too, but interestingly, in the last few years, Germany has decided to completely get away from using nuclear power. And you see China is low here, but China's energy needs have been so great that they are on their way up in nuclear power. They're also building a lot of coal plants as well. All right, now, what will be the energy of the future? One thing that people have been working on for a long time is fusion. Fusion is like the opposite of fission. In this, you take small nuclei and you slam them together and make larger ones. This is exactly what the sun does to produce energy. Sun takes hydrogen 1, just normal hydrogen. It goes through a relatively complicated process and slams those together and makes helium 4. That's just normal helium. So what the sun is doing right now is it's changing hydrogen into helium, and when it does that, huge amounts of energy are given off. You know, the sun is a huge source of energy for us. Now, in order for the fusion to work right now, it takes temperatures around 40 million kelvins, tremendously high temperatures, to get these particles to stick together, to fuse them together. So it has so far been impractical on Earth to do fusion for energy generation because you have to have high temperatures and it takes a lot of energy to get the reaction started, and right now they haven't even been able to get enough energy out of this to make it worthwhile. The sun does it. We do in nuclear bombs use this reaction, but we don't use it for energy. Now, one place it is used is, again, in the sun. All of the elements that we are made of, that the Earth is made of, that we know of, were built up in stars by a process known as nucleosynthesis. So that is the making of nucleuses. And here's one of the chains that can happen. Hydrogen fuses in the sun to make helium. Now, eventually, this hydrogen will run out. There'll be helium left. Heliums will react with each other, will fuse together to produce carbon. Carbons with another helium might make oxygen. Oxygen with another helium will make neon. And we can do these processes of fusing together nucleuses up until we get to about iron. And after that, the processes have to get more complicated. And you take something more complex than our sun to do that. And there have been stars, huge stars, much bigger than our sun. And in those, and in the explosions that rip them apart, other elements are produced. And so there is an old saying that we are all the dust of stars because all of the atoms that we're made up of were originally built up inside of a star.